bit of expanding brackets. Week 4, question 1. 3 times by 4a is going to give me 12a. 3 times minus 5b is going to give me minus 15b. Plus 4 times by 3a is going to give me plus 12a. And plus 4 times by b is going to give me plus 4 lots of b. Let's be careful. 12a, add another 12a, gives me 24a. And then minus 15b plus 4b. Be careful with your negatives. I'm on minus 15. I'm going 4 up from there. I get minus 11b. Next one. 5 times by a is 5a. 5 times by minus 5b is minus 25b. And then minus 3 times by 2a gives me minus 6a. And this is where people might make a mistake. Minus 3 times by b is going to give me minus 3b. So 5a take away 6a is going to give me minus 1a. And minus 25b take away another 3b is going to give me minus 28b. Question 3, I've got dividing mixed numbers. So probably best way to do it is to convert it into improper fractions. So I've got 5 10/5 in 2 wholes, and another 3/5 gives me 13/5. And then I'm going to divide that by 4, 5, 6, 7 quarters. So I'm going to use the multiplicative inverse. So that is the same as 13/5 times by 4/7, which is going to give me 13, 26, 52 over 35, which is the same as 1 whole, and by 45, 17/35. Question 4. 1 1/3 divided by a half. With these ones, guys, if you're dividing by a half, it's just the same as multiplying by 2. How many halves go into it? So I can see straight away my answer is going to be 2 2/6. If you want to do it with the full conversion, that's fine. But dividing by a half is the same thing as multiplying by 2, so you should have that locked in your head. So I would have 4/3 divided by a half. If you want a full method, which is 4/3 times by 2 over 1, which is 6, 8 over 3, which is 2 wholes and 2/3, which we mentioned at the start, because if you're dividing by a half, it's the same as timesing by 2. Question 5 is BIDMAS. So there's a multiplication, there's a multiplication. There's no brackets, there's no indices. I'm going to do those ones first. So I've got 8 and I've got 48, and I'm going to add them together, and that's going to give me 56. This time we do have some brackets, so that comes first in the order of operations. So I've got 5 times 8, which is 40. Factorizing fully, I'm looking for common factors of the coefficient. So highest common factor of 6 and 30 is 6. And then of the variable as well. Highest common factor of x cubed and x is just x. And that's going to be multiplied, therefore, by x squared minus 5. Question 8. Factorizing. I'm looking for highest common factor of 77 and 33. I'm thinking it's 11. And then, and I need the x as well. I need the highest common factor of the variable as well, x and x squared, which is x. So inside here I'm going to have 7, because 11x times 7 will give me 77x. And I'm going to have minus 3x, because minus 3x times by 11x would give me minus 33x squared. Next question, standard form. This is, if it's in standard form, it needs to be with a decimal point there. So what's happened is it's been divided by 1,000. So it's the same as 7.67 times 10 times 1,000, or 10 to the 3. And it's the same deal here. It's just times by 1,000, so it's going to be 5.67 times by 1,000, which in standard form we're going to write as 10 to the 3. Right, geometric progressions means we multiply, the word is common ratio. We multiply by a common ratio. In this case, the common ratio is 5. And we're going to work out the next 3. So the next one would be 100 times 5, 500. The next one would be 500 times 5, 2,500, and the next one would be 2,500 times by 5, 12,500. Common ratio in the next question is 3. So I go from 4 to 12, I multiply by 3. 12 to 36, I multiply by 3. This is when it gets a little tricky. Right, 36 times 3, 30, 90, 108. 108 times 3, 324, is it? Seems like it is. 324 times 3, 972. I believe. Let me know if I'm wrong. Okay. Next question. Question 13. 17.9 times by 6.3. I would do 179 times by 63. With whatever method you have, I trust you that you have a good column method or a grid method. If you are not sure about that, then you need to make sure you work on it, but I think you probably are. And that gives me 11,277, 11,277. But what's happened, that's been multiplied by 10 to change it. That's been multiplied by 10, so the whole thing's been multiplied by 100, so I have to divide by 100, 112.77. Does that seem about right? Well, if it's about 20 times by about 6, that would come to 120, so it's in that area, so it's definitely right. 13.6 divided by 0.8. I'm going to put it like this, and then I'm going to use my equivalent fractions to work this one. So that's going to give me 136 divided by 8 if I just keep the equivalent fraction by multiplying top and bottom by 10. So then a little bus stop method. How many 8s in 136? Well, 8s into 13 goes once. I've got 5 left over. And 8s into 56 goes 17 times. So my answer is 17. There's no need to change anything there to readjust at all, because I kept the values. 13.6 divided by 0.8 is the same as 136 divided by 8. The fact that I've multiplied both top and bottom by 10 means that nothing has really changed there. Okay, the value has not changed. I've just made it easy for me to work out. Question 15. Make x the subject of this formula. I need to think about how x has been packaged up. And what's happened with x is a has been added to it, and then a square root has been taken of the whole of x plus a. So I need to undo it in reverse. So the first thing I'm going to do is to square. And I'm never quite sure how to write, how to sort of show that I'm going to be squaring both sides, so I probably just write it all out. So square. So that's going to give me y squared on this side and x plus a on this side, and then I just need to take away a from both sides, and that's going to give me y squared minus a equals x, and I've changed the subject of that formula. And with this next one here, x squared plus a, this time think about how x has been packaged up. It's been squared first and then a has been added to it. To get back at it, I'm going to have to reverse that process. So I'm going to take a away from both sides. Gives me y minus a equals x squared, and then I'm going to take the square root of both sides. So that gives me y minus a, the square root of that, equals x. Question 17. Expand and simplify. So I want a quick FOIL. F-O-I-L. First, outer, inner, last. If you've got a different method, that's fine. First, x times x gives me x squared. X times 5 gives me plus 5x. Minus 5 times x minus 5x. Last, minus 25. This, guys, is called the difference of two squares, because the x's disappear, the single powers of x disappear, and that just leaves you x squared, which is one square, take away 25, which is another square, and that's why that particular formulation is called the difference of two squares, but you'll learn that more in year 9 and year 10, because you can make use of that in good ways. FOIL here, x squared first, outer minus 1 lot of x, inner plus 5 lots of x, and last minus 5. So it gives me x squared minus 1x plus 5x gives me plus 4x, and then minus 5. Question 19 rather. We're just going to treat this as a normal fraction, so we need a common denominator, so we're going for 40 as a common denominator. That's been multiplied by 5, so the top's been multiplied by 5, 5x. That's been multiplied by 8, so top's been multiplied by 8, so 16x. And that's going to give me 21x over 40. Can't simplify it. I think we did on previous homeworks, we also, just worth noting, that's the same thing as 21/40ths of x. Okay, and then last one, same deal, out of 30 as a common denominator, times by 5, 25x, times by 6, minus, so this is going to be 16x, take those away, 25, take away 16 is going to give me 9x over 30. Now this time I can simplify it. Okay, so I've got, yep, it's 12. I timed 2 by 6 and got 16, didn't I? Right, 12x, thank you very much. Good spot, guys. So that's going to give me just 13x over 30, and I can't simplify that. Done.